Hello and welcome to my channel if you are new. Today we're going to be talking about how a wing works. Here I have a diagram of a airfoil. In case you don't know what that is, that's basically if you cut a slice out of a wing, you would see this. So here is the wind or the air going to the plane, which is here. And then here's the angle of attack, which literally just means what the angle of the wing is compared to the horizon. Okay, so basically you may have learned in school that an airfoil works something like this. Basically, let's change that. I don't like red for this diagram. Okay, maybe you've learned that an airfoil works by air passing through, or below, and then like that, and then air passing above. And then now, clearly above, obviously, there's more distance for the air to travel. And they say that the air has to meet at the same time, which isn't necessarily true. I'll explain that later. And also, according to the Bernoulli's principle, the faster, which it goes for a farther distance, and it meets at the same time, so it's faster. The faster air has less pressure, and the slower air has more pressure, meaning that it will essentially pull the plane up. But that's not necessarily true, because some planes can still fly upside down. And if you see, I'm not going to show it here, but the airfoil of the Wright brothers plane, in fact the first plane, and also many World War I planes, were like this, which makes absolutely no sense, because, well, it's the same distance, because it's like a flat plate. So, how does that work? Okay, now I will explain that after I erase all this, yeah, there we go. Okay, so here's our diagram, and we'll use, how does that look like? That looks good. We'll use this blue to represent the air. Okay, so the air is going this way first, and then once we reach the wing, it hits, right? But when it hits, it can't just go like this, because that's just not how air works. So when it hits, it slides down, follows the airfoil, and gets pushed down. That makes sense, right? Now, if the air hits here, it will also get pushed down. But the air doesn't have to necessarily hit at the bottom. It might go here. Now, what happens there? It's gonna get deflected up, but then, according to Coanda's effect, which states that a fluid will always follow the sides of an object, this can be demonstrated by using a wine bottle or a glass bottle of any sort, or a cup. And then if you pour it very slowly, the water will actually follow the cup to the bottom and it will spill out, which is really annoying. But anyways, yeah, that's how it works. So it will actually follow the wing and then maybe leave there, I don't know. And then some of it will follow the wing and go down all the way there. I picked a bad example for this picture because that's an extremely high angle of attack. That's crazy. Okay, so it will all, notice most of them will go down. Now, some of the air, of course, will just become turbulent. Bam, bam, bam. Don't mind my bad drawing. We'll do that, and then not go down. I don't know. Like that, maybe. And then like that. And then it won't go down. But most of them, as you can see here, will go down. So it will push the plane up because it's going down. So according to Newton's something law, I don't remember. I'm sorry. I don't remember. One of his laws states that if there's any action, there must be an action opposing it. So there's a downforce, which means that the plane will go up. Yeah. Basically that. But see how I was talking about turbulence? In this case, well, this is kind of explaining how planes stall, if you know what that means. Basically, a stall is where the plane stops generating lift. Now, this may happen because the plane is just not getting enough air, but this can also happen when the angle of attack is too high. Okay, so I'm going to be explaining that. When the angle of attack is too high, like this, right here, the wind will follow down, yes, pretty nice. But some of it that goes over, just like, it doesn't go down. None of it goes down. So this whole entire upper part is useless. And then the lower part, since it's like less lift, the lower part will have to do way more work. But it can't do that because the work will stay the same. So it just like stops flying properly. Yeah. That's basically it. Thanks for watching.